of 9 is digital sum must be digit must end with 0. Divisibility of 11 is nothing but difference of alternative digit summation must be equal to 0 or any multiplier of 11. Divisibility of 12 is nothing but number should be divisible by 3 and 4. There are so many different rules. So, and all the rules together, so came from divisibility rule only, like a remainder theorem concept only. All the rules are developed using the remainder theorem concept. So I'm just taking a very simple number. Let's assume my number is ABC. I'm assuming a number as ABC. Generally, all the numbers which we are dealing with are called as a decimal number, are nothing but base 10 numbers. So when you take a 3-digit number as ABC, when you divide ABC with 3, what is the remainder is the question. I'm trying to develop the rule. So what is ABC base 10? If you expand ABC base 10, C into 10 raised to the power of 0, B into 10 raised to the power of 1, plus A into 10 raised to the power of 2, divided by 3, divided by 3. So as we know, we discussed A plus B plus C. So we can go with the individual reminders. So I'm going with the individual reminders as C into 10 power 0 divided by 3 plus B into 10 raised to the power of 1 divided by 3 plus A into 10 raised to the power of 2, that is 100 divided by 3. We can find out the individual reminders. So what is 10 power 0? It is 1. 1 by 3 is 1. 1 into C is going to be C itself. The remainder here is C. 10 by 3 is nothing but we are getting remainder as 1. So 1 into B is B. 100 by 3 you are going to get a remainder as 1. So that is nothing but A. So what are the reminders which we are getting? I'm sorry, screen is not visible. I guess now the screen is visible. So ABC base 10. See why I have taken like this is the reason is this. See, for example, you have any number 123. So what is our number system? We call our number system as a decimal number system. So 123, if you look at 123 base 10. So what is the meaning of 123 base 10? 3 into 10 raised to the power of 0 plus 2 into 10 raised to the power of 1 plus 1 into 10 raised to the power of 2. So 10 power 0 is nothing but 1, 10 power 1 is nothing but 10, 10 power 2 is nothing but 100. That is the reason we call this 3 as going to be 1's digit, 2 as going to be 10's digit, 1 as going to be 100's digit. 3 into 1 is 3, 2 into 10 is 20, 1 into 100 that is going to be 100. Overall, the resultant is going to be 123. Overall, the resultant is going to be 123. That's how we can say. The same thing I'm doing here. I'm randomly taking a 3-digit number. I'm trying to describe or I'm trying to take the explain the rule of divisibility of 3. For that, I'm randomly taking a 3-digit number. So let's assume that ABC is a 3-digit number. ABC is a 3-digit number. ABC is a 3-digit number. ABC base 10. So if you expand this, this is going to be C into 10 raised to the power of 0 plus B into 10 raised to the power of 1 plus A into 10 raised to the power of 2. This is the expansion. If you divide this number with 3, what happens if you can observe? If you divide this number, you can individually divide these numbers. So you can observe 10 power 0. 10 power 0 means what? 10 power 0 is nothing but 1. 1 by 3, what is the remainder? 1. C by 3, what is the remainder? C. C into 1, C by 3 is going to be left with the remainder which is equal to C only. Similarly, if you observe the second one, 10 by 3, what's the remainder? It's going to be 1. B by 3, remainder is going to be B. B into 1 is going to be B, so remainder is going to be B here. 10 square is 100. 100 by 3, what's the remainder? 333s are 99, we left with the remainder as 1. A by 3, remainder is A. So what is the overall remainder here? Remainder is A. So what is the remainder of this whole expression is the question. So we are getting C plus B plus A because the operation between them is this. So we can say the remainder is going to be this. What is this? Similarly, if you have 123, if you divide with 3, what is the remainder if it is a question? You can just do individual numbers. 3 plus 2 plus 1. What is 3 plus 2 plus 1? 6. What is 6 by 3 remainder? 6 is a multiplier of 3. So we left with nothing. So similarly, any other number is there, you can take the individual digit summation. You don't need to calculate. For example, 103 divided by 3. What's the remainder? You can just do 1 plus 0 plus 3. What is this? 4. 4 by 3. What's the remainder? 1. So that means that is the reason the rule came into the picture as finding the sum of the digits. Sum of the digits. If sum of the digits is divisible by 3, then we can say whole number is divisible by 3. That's how the rule is developed. So same thing, if I want to check out, just for understanding or clarification purpose, if I want to check out what is the divisibility rule of 2, let's assume I am trying to check out what is the divisibility rule of 2. So how can I check the divisibility rule of 2? The same calculation part is going to be involved. So please observe what is the rule of 2 as we studied. Rule of 2 is nothing but number must be having the last digit which is ending with 0, 2, 6, 4, 8 or otherwise must be even number. So if you divide with the 2, what happens if you can observe? 10 power 0 is what? 10 power 0 is nothing but 1. 1 by 2 remainder is 1. C into 1, we are going to get a remainder as C here. But when you look at this, 10 by 2, what is the remainder? 0. 10 square by 2, what's the remainder? 0. So we'll get all the reminders which is equal to 0. So remainder will depend upon only what? This is C. C means what? That's the last digit. That's the reason the divisibility of 2 is going to be the number should be divisible by 2 if and only if last digit must divisible by 2 or last digit must end with 0, 2, 4, 6, 8. So that's a rule came into the picture. So that's what that's how the things will be there in under the divisibility rule. That's how we can prove the divisibility rule of each and every number, not only this number 2, 3, 4, everything you can prove. So let's try for that and make sure how it is going to be possible. So let's look at divisibility of 11. So let me discuss some rules here, then we go with the questions. So I'm just trying to keep all the rules which are similar. I'll keeping here. Divisibility of 2, divisibility of 4, divisibility of 8. These are similar. Divisibility of 2 is nothing but a number is divisible by 2 if the last digit is divisible. Divisibility of 4 is nothing but a number is divisible by 4 if and only if last 2 digits are divisible. Divisibility of 8 is nothing but we can say last 3 digits are must be divisible. So let me take an example. So 462 divisible by 2. So let me take another example. 324 is it divisible by 4? Check the last 2 digits. Check the last digit. So if the last 2 digits are divisible by 4, we can say the entire number is divisible by 4. 5024 is it divisible by 8? You can check last 3 digits. That is 024 divisible by 8. So like that, any number divisibility rule, you can use this kind of rule and find out. 2, 4, 6, 8 will follows the rule. 2 is nothing but last 1 digit. 4 is last 2 digits. 8 is nothing but last 3 digits. Similarly, divisibility of 3 and divisibility of 9 is going to be similar. What is divisible by divisibility of 3 is nothing but divisibility of 3 is trying to say that the digital sum must be divisible by 3, and divisibility of 9 is nothing but the digital sum must be divisible by 9. So for example, I have a number as 312. Is it divisible by 3 or not? If it is a question, I can just take the sum of the digits. 3 plus 1 plus 2 is giving a result as 6. 6 is divisible by 3. We can say the entire number is divisible. Similarly, what is the divisibility of 8? So 8 divisibility, if you want to check out, you can take a very simple number. For example, I am taking a number 729. Is it divisible? Sorry, divisible by 9 or not is a question. So in order to check the divisibility of 9, 3 and 9 follows a similar rule. Sum of the digits must be divisible by 9. So I have a number 729. 7 plus 2 plus 9. What is the sum of the digits? Sum of the digits is going to be 18. Is 18 is divisible by 9? Yes, 18 is divisible by 9. So we can say the entire number is divisible. So like that, you can observe whatever the number is there. So the sum of the digit must be divisible by 9. Then we can say that is divisible by 9. Sum of the digits must be divisible by 3. Then we can say must be divisible. So all the numbers which are divisible by 9 must be divisible by 3, but vice versa is not possible. That means all the numbers which are divisible by 3 may or may not be divisible by 9. So next, divisibility of 5 and divisibility of 10 will be similar. A number is said to be divisible by 5 if and only if the last digit is ending with 0 or 5. A number is said to be divisible by 10 if and only if the last digit is ending with 0. Last digit is ending with 0. Similarly. So divisibility of 11, very important rule. Divisibility of 11 is nothing but difference of alternative digits summation should be equal to 0. Alternative digits summation, difference of alternative digit summation should be equal to 0 or any multiplier of 11. That means that, for example, you have any number. Let's assume that I have a number as going to be 121. Whatever the number is there, if you want to check out the divisibility with 11, what you can do is go with the difference of alternative digits. Start with this, go with the alternative. 1 plus 1 is 2. So what is the leftover middle number? That is going to be 2. Difference of this is 0. We can say this number is divisible. We can say this number is divisible. So let's assume that I have a number as going to be 156 is there. So 154 is there. Is this number is divisible by 11 or not is a question. What you need to do is go with the difference of alternative digit summation. So start with this, go with the alternative. 1 plus 4 is 5. 1 plus 4 is going to be 5. So the middle number is 5. Difference of these two is going to be 0. We can say this number is divisible. So the next one, for example, you have a number, any number, 1, 0, even 4-digit number also. Very simple. Whatever the number is there, start with 1, go with the alternative. So 1 plus 0 is going to be 1, 0 plus 1 is going to be 0. Difference of alternative digits summation should be equal to 0 or any multiplier of 11. So difference of this is 0. So we can say that number is divisible. We can say that number is divisible. So divisibility of 11 is nothing but this. Difference of alternative digit summation should be equal to 0 or any multiplier of 11. Should be equal to 0 or any multiplier of 11. So for example, 9 is there. Is it divisible by 11? 9 plus 9 is 18. 9 plus 9 is 18. Difference of this will be equal to 0. We can say that is divisible. So like that, any number divisibility, you can divisibility of 11 you can use like this. And divisibility of remaining numbers. Remaining numbers means especially I'm talking about the divisibility of the numbers. Divisibility of the numbers which are composite numbers. Divisibility of 6, divisibility of 12, divisibility of 18, divisibility of 24, and all these numbers. 6 is nothing but we can say 2 into 3. 12 is nothing but we can say 3 into 4. 18 is nothing but, so that means you can write it as a product. So that means what is the divisibility of 6 means a number is said to be divisible by 6 if and only if it is divisible by 2 and as well as 3. Divisible by 12 means it must be divisible by 3 and as well as 4. Divisibility by 18 means it must be divisible by 2 and as well as 9. So you can write it as a product of two numbers. The two numbers should not have any common factor other than 1. So if it is 6 is there, I can write it as 2 into 3. 2 and 3 never goes in a single table. So 12 we can write it as 2 and 4. 3 and 4. 3 and 4 never goes in a single table. So but if you take it as 2 and 6, 12 if you write it as 2 into 6, in 2 table you will get 6. So that kind of pair we should not take. We should take a pair where the numbers should not have any other common factor other than 1. So those are numbers called as co-prime numbers. So for example, if it is 24, how can we write 24? We can write it in so many ways. So we can write as 2 into 12, or we can write as 3 into 8, we can write it as 6 into 4. But you have to choose a pair which is not having any other common factors other than 1. So that means 24 I can write as 3 into 8, 3 8s are 24. 3 8s are 24. 3 and 8 are co-prime numbers. That means in 3 table you never get 8. So like that you have to split the number as a product of co-prime numbers so that it would be easy to tackle. See, for example, I want to know what is the divisibility rule of 36. Can you tell me what is the rule of 36? 36 how can we write? If I write it as 9 into 4, 9 4s are 36. 4 and 9 are not having any other common factors other than 1. So that's a better pair to take. For example, 90 is there. What is the rule? 9 into 10. So like that, any other composite number is there. In order to find out or extract the divisibility rule of it, you can just check out. The numbers should be co-prime numbers. I hope the point is clear. Let's look at some of the practice questions so that you will get some clarity on it. If a number 7x86038 is exactly divisible by 11, what is the smallest number which we can place in the place of x? So what is the divisibility rule of 11? First, you can try to understand. Divisibility of 11 is nothing but difference of alternative digit summation must be equal to 0. So we have a number 7x86038 is there. Is exactly divisible by 11. What is the value of x is the question. So difference of alternative digit summation should be equal to 0. That's a rule, right? Difference of alternative digit summation should be equal to 0 or any multiplier of 11. 0 or any multiplier of 11. So let me look at what is the difference of these alternative digits. So 7 plus 8, what is 7 plus 8? It is going to be 15. So 15 plus 0, that is 15. 15 plus 8, that is giving a result which is equal to 23. So this is one set. The other set, if you observe, x plus 6 plus 3, that is nothing but 9 plus x. So difference of these alternative digits must be equal to 0, or otherwise difference of these alternative digits must be equal to 11. Difference of these alternative digits must be equal to 11, any one of these two. So if you are getting x value as negative, you can ignore it. If you have to get a positive value, that's why I'm sharing these two. So if it is 23 minus 9, so you are going to get a result which is going to be 14. So 14 minus x is equal to 0. From this, I am getting x value as 14, but x cannot take this two-digit number. It's a single-digit number. So that's why this is not a possible value. So we can write 14 minus x is equal to 11. So from this, what is the x value? X value is going to be 14 minus 11. That is going to be 3. Available as B. Mark it as answer. Available as B. Mark it as answer. Let's look at one more question. So the question here is 5425x6 is completely divisible by 8. What is the possible value of x? When the number is said to be divisible by 8, last 3 digits. What are the last 3 digits here? 5x6. X value is already available in the option choices. What is the first option? Becomes 536. What is the second option? 586. What is the third option? 576. What is the fourth option? 546. When it is divisible by 8, you can check out if you manually calculate. So it is 536. So 8 6 are 48. We left with 56. 8 7 are 56. It is divisible. But they are asking us to find out the least value which can be assigned for x, and this is the only one least value which we are able to see. So we can mark it as option A. So just look at, I'm taking x value, I'm plugging x value as 3. Then it is 536. So 8 6 are 48. We left with the remainder which is 56. 8 7 are 56. Completely divisible. We can say the value is going to be 3. Let's look at the next question which is available on the screen. So what could be the value of x to make the number 3 4 5 6 7x must be divisible by 9. So to make this number as divisible by 9, what is the x value? So what is the divisibility rule of 9? 9 divisibility is nothing but the digital sum must be divisible by 9. So what is the digital sum here? 3 plus 4 is 7. 7 plus 5 is going to be 12. 12 plus 6 is going to be 18. 18 plus 7 is going to be 25. 25 plus x must be divisible by 9 is the question. 25. What is the x value? X value must be 2. You can mark the answer choice as going to be T. Why? Because 27 is divisible. So look at the next number. So the question here is the number 3 4 5 star 7. That means star is some digit. So it is completely divisible by 3. The smallest digit which can be placed in place of star. So what is the divisibility of 3 is also same, right? Sum of the digits. What is the sum of the digits here? 3 plus 4 plus 5 plus 7. If you check out, 3 plus 4 is going to be 7. 7 plus 5 is going to be 12. 3 plus 4 is going to be 7. 7 plus 5 is going to be 12. 12 plus this is going to be 19. 19 is nothing but 1. What is the extra part which we have to add is that is going to be 2, so that it will be divisible. Like that you can apply. So let's look at this question. 4 6 7 xy is completely divisible by 90. What is the possible value of x plus 1? What is 90 means? 90 means 9 into 10. When the number is said to be divisible by 10, it is last digit must be 0. That means y is 0. When the number is said to be divisible by 9, sum of the digits. So 4 plus 6 plus 7 plus x plus 0 should be divisible by 9. What is x value? So this is giving a result as 17. 17 plus x plus 0. So 17 is not divisible. What is the least possible value of x to make it divisible by 9? X must be 1. So what is the value of x plus y is the question. X is equal to 1, y is equal to 0, x plus y is equal to 1. Mark it as option B. Look at the next number which is available on the screen. 58378 is completely divisible by 11. What is the possible value of A? So you can observe this is going to be 8 plus 8, it is 16, and minus 7 plus A is must be equal to 0. 16 minus 7 is going to be 9. 9 minus A is equal to 0. A value is going to be 9. Available as D. You can mark it as answer. What is the value of m comma n when it is divisible by 8 and 11 is a question. M and n are the single digit numbers. So divisible by 8 and divisible by 11. So what is the divisibility of 8? Last 3 digits must be divisible. What are the last 3 digits? This is 5, 8, n. So n values are available here. So if you put n value as 8, then what is this 588? Is it divisible by 8 or not? 8 7 are 56, we left with 28. No, not divisible. If you plug it as 6, it is 586. 8 7 are 56, we left with 23, not divisible. If you plug it as 4, 8 7 are 56, we left with 24. Remainder is 0. It is possible. Even this is also possible. So let's look at what is other possible value of m. So these two are possible, these two are not possible at all. So m value, I'm just plugging option C here. If you plug C here, this is 639048458 Is it divisible by 11 or not is a question. You can check with the difference of alternative digits. So 6 plus 9 plus 4 plus 4 plus 8 plus these values are the things. 6 plus 9 is going to be 15. 15 plus 4 is going to be 19. 19 plus 4 is going to be 19 plus 4 is going to be 23. 23 plus 8 is going to be 31. What is the other numbers? You can observe 3 plus 0, 3, 3 plus 8, 11, 11 plus 5 is going to be 16, 16 plus 4 is 20. Difference of this is 11. So it is divisible by 11. So possibility is going to be option C, eliminate option B. That's how we can solve. So I hope you are able to get a clarity. And to do some more practice questions, I'm just sharing these questions. Practice question number 1. Take the screenshot. Practice question number 1. We'll wind up the session here. We'll continue the session in the next class. Practice question number 1. All of you to solve the questions. First of all, your task is derive all the divisibility rules. I have explained now what is the divisibility rule of 2 and 3. Like that, every number you can derive. Derive all the divisibility rules. Try for those. When you are deriving, what you have to remember is look for the power of 10 where it is divisible by the denominator. It can be 2 divisibility or 3 divisibility. Convert into base 10 numbers and apply your divisibility rule. How I applied for 3. You will get everything. Practice question number 2. Practice question number 3. Anyways, we'll have a discussion for all in the next session. Practice question number 3. Practice question number 4. Practice question number 5. Practice question number 6. Previous TCS question. With that, we'll wind up. Practice question number 6.